What's up, you freaking geniuses? So in this video, I'm going to teach you how to write coordinate proofs of circles. All right, so we're going to go over two examples. Let's start with this one right here. So this one just says prove or disprove the statement. So it says the point 2, 3 lies on the circle centered at the origin with radius 8. All right, so I think a picture is normally pretty helpful. So let's graph this little circle right here. Okay, so it says the center of the circle is at the origin and it has, so we'll draw our circle, and it has a radius of 8. Okay, so we're just trying to figure out if the point right here, 2, 3, actually lies along this circle, right? So 2, 3 would be about here, right? So we're just trying to see if this point really does actually lie on the circle. How can we do that? Well, what is the distance from the origin, right, the center of the circle, to this point, 2, 3? Is it actually 8 or is it something else? So in order to see what this distance actually is, let's use the distance formula. So that formula is the distance between 2 points is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, all right? All of that is under the square root. Okay, and the two coordinates that we want to use here are the origin, right? So that's at 0, 0, and this other point that we're looking for, 2, 3. So let's label 0, 0 as x sub 1 and y sub 1, and 2, 3, we'll just label that one as x sub 2, y sub 2. Okay, so if we plug those into the formula here, we're going to get that the distance is equal to the square root of x sub 2 minus x sub 1, so that's going to be 2 minus 0, 2 minus 0 squared, plus y sub 2 minus y sub 1, so 3 minus 0, right, 3 minus 0 squared, and that's going to be equal to the square root of 2 minus 0 is just 2, right, so here we just get 2 squared plus 3 minus 0 is just 3 squared, so this is equal to 2 squared is 4, and 3 squared is 9. So this is equal to the square root of 13. Okay, now, I don't know what the square root of 13 is off the top of my head. The square root of 9 is 3, and the square root of 16 is 4, so this is going to be somewhere between there, which is a lot less than 8, right? So that just means this point right here, 2, 3, doesn't actually lie on the circle. It lies a lot closer to the circle, probably around here. 2, 3 is probably around somewhere in there. Okay, so here we have disproved this statement, right? This point 2, 3 does not lie on this circle that has a radius of 8. All right, let's try one more here. So this one just says prove or disprove the statement. So the point square root of 6, 2 lies on the circle centered at the origin and containing the point 3, negative 1. All right, so again, I think drawing a picture is probably going to be kind of helpful. So here, let's see, it says the circle centered at the origin. So there's the center of the circle, and it contains the point 3, negative 1. All right, so let's draw our circle like this. And 3, negative 1 is, let's say, here. Okay, so this is 3, negative 1. Okay, so we know this point lies on the circle because it tells us, right? So what we want to check is if this point right here, the square root of 6, 2, also lies on this circle. So the square root of 6, that's somewhere between 2 and 3, right? So we can say maybe somewhere around here. And then if we go up to, so maybe there-ish, all right? So we're going to say this is about where the square root of 6, 2 is. Okay, so how do we know if these 2 points actually lie on the same circle? Well, the distance from the origin to each point should be the exact same, right? This radius should be equal to this radius if they both really are on the same circle. So in order to find those radii, we can again use the distance formula. Okay, so let's label the origin again as x sub 1, y sub 1, and let's check this one first, 3, negative 1. So this will be x sub 2, y sub 2. So then here we're going to get that the distance is equal to, I'll just write it really quick, x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So then the distance is equal to, let's make it longer, x sub 2 minus x sub 1 is 3 minus 0 squared plus y sub 2 minus y sub 1 is negative 1 minus 0 squared, and that's equal to the square root of 3 squared plus negative 1 squared, and that's equal to the square root of 9 plus 1, which is equal to the square root of 10, all right? So this radius from the center to this spot right here, 3, negative 1, is equal to the square root of 10, okay? Now, let's check the distance from the origin to our other point over here. So let's delete some of this stuff. All right, so let's delete this so we can label this other point now. So this will now be x sub 2 and y sub 2. All right, so now let's plug these into the formula so that here we're going to get that this is equal to the square root of x sub 2 minus x sub 1. So that's the square root of 6 minus 0 squared plus 2 minus 0 squared. So then this is equal to the square root of 6 minus 0 is just the square root of 6, and that's squared, plus 2 squared. So this is equal to the square root of 6 squared. Those cancel out, so we're just left with 6 in there, and 2 squared is 4. So here we also get the square root of 10, all right? So the distance from the origin to this other point is also, again, the square root of 10. So since they're both the same distance away from the origin, that means both these points lie on the same circle. Okay, so here we have just proved that this point, square root of 6, 2, lies on the same circle containing this other point, 3, negative 1. Boom.
So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below.